Okay, I think we'll get started then. Thank you, Emily. For those of you who are wondering who is on the other line, my name is RJ Matetic. I serve currently as the Director for the Pittsburgh Mining Research Division of the NIOSH Mining Program. Welcome to today's webinar, the Mining Hearing Loss webinar. Let me see if I can get these slides to advance. Okay, here we go. So as I mentioned, I serve as the director for the Pittsburgh Mining Research Division, but I also serve as the manager for the mining sector portfolio, along as the manager for the hearing loss cross sector. So this webinar is obviously of very interest to me as well, because of the mining and hearing loss involvement that I have. So let's get started. If you're not familiar, and I think all of you that are on the line are familiar, the NIOSH program portfolio has been organized into sector programs that represent industrial sectors and 7 health and safety cross-sector programs. Then these are all organized around health outcomes based upon NORA, which is the National Occupational Research Agenda. This webinar today addresses as you can see on the slide, the mining sector and actually the hearing loss prevention cross-sector issue for the particular sector that we're discussing today, and that is mining. Okay, this next slide kind of just gives you an idea of hearing loss in the mining industry itself. These were 2 studies conducted, and these studies actually looked at percent hazardous noise exposure in different classifications of the NAICS system. And the one on the right shows the percent of hearing impairment regarding those different types of industrial sectors. So as you can see from this slide, mining has the highest reporting hazardous noise exposure, and also mining has the highest percent regarding hearing impaired workers. So, you know, mining and hearing loss prevention, mining noise-induced hearing loss is a critical problem for the sector itself, as you can see from the slide and the studies that were conducted regarding it. Today, this webinar will provide research-based information and solutions to prevent noise-induced hearing loss. As you can see from this slide, we're guided by the hierarchy of controls and recommend the most effective controls that eliminate noise at the source first. We've actually simplified this hierarchy of controls through what we call is our CAP acronym. And that is, the C obviously stands for control and reduce or eliminate noise at the source as the most effective approach, utilizing engineering control technologies. The A, avoid noise sources, where those would be our administrative controls. And finally, the P, protect your ears. And that's where you're going to hear some discussion regarding hearing protection devices today as well. So, you know, I can add that if any on this call were interested in stickers regarding Cap the Noise, feel free to reach out to any of us, and we'll make sure that you receive those. So, getting on with the webinar. During this mining hearing loss webinar, you'll hear from 4 leading researchers in this particular area. First, you will hear from Dr. Rick Neitzel. Dr. Neitzel is from the University of Michigan, and Rick will talk to you about the many negative effects noise can have besides just hearing loss. And then we will go into the hearing loss prevention in mining. Dr. Hugo Camargo from NIOSH will talk about noise control solutions. Dr. Amanda Azman from NIOSH as well will talk to you all about effective hearing conservation approaches. And finally, Dr. Bill Murphy from NIOSH will talk regarding fit testing hearing protectors and achieving maximum protections utilizing those technologies. So I hope the webinar is very informative to all of you. On behalf of the mining program and the hearing loss cross-sector, I'm excited to see all these names on my screen participating in this webinar, and I will then move this over to Rick to start the first presentation on non-auditory effects of noise. Rick?
Yes, great. Thank you so much for the introduction, RJ, and it's a pleasure to be here to chat with you all this afternoon. I'm looking at the list of attendees here and see some familiar names, but some new ones as well. So hopefully this will bring some information to everyone's awareness that they didn't already know. So if I could grab control of the screen here. There we go. So I very much appreciate the invitation to come and talk to you about non-auditory effects of noise. Again, this may be news to some of you. I do want to say, though, that I want to take the first couple minutes here just to make those of you on the phone aware of a new resource that's available here. So we here at the University of Michigan in my lab received some funding from NIOSH to create a new tool to allow occupational health and safety practitioners as well as researchers to try to understand better what trends are with regards to noise exposure. So I'd just like to introduce you here to what's now available online free of charge, a National Job Exposure Matrix, or GEM, for noise exposure. So this is really the first tool that's been developed that, again, is designed to allow you as a user to access this website. So in fact, you can see if you go to the website linked here, you can actually search for different job titles, different industries, different NAICS codes, and this GEM is going to draw on actually over 1 million noise measurements to estimate for you what your exposure might be for whatever category you've happened to type in. And so I do want to take a moment here and just bring to your attention some of the high-level results that we've already done in our own analyses of this data set. So obviously this is a mining sector webinar, but many of you will also have workers who are covered by OSHA, maybe for some of your above-ground operations. And so we have obtained from OSHA and other sources actually close to 1 million measurements, as you see here, of noise. And so what I want to highlight here in not great detail, but on the graph on the right, we're actually able really for the first time to do this over a 40-year period almost, to look at what's the average noise level over time, so going from 1979 all the way up to 2013. So what's the average noise level for compliance measurements made in each of these years, as well as what's the fraction on the right-hand axis here, the fraction of measurements that exceeded the action level of 85 decibels or the PEL of 90 decibels according to OSHA. And so I don't want to get too much into the data here, but I do want to highlight that we can start to draw some trends over time. So in these dark lines at the top of the graph, this corresponds to the mean action level measurement made by OSHA, as well as the percentage of measurements that exceed that action level of 85 decibels. And so we can actually see in the U.S. over time, it does appear like noise levels are going down according to those action level measurements. We can see the same trend down at the bottom of the graph here for our PEL measurements. So there does seem to be a downward trend here. That's good news. That means that in this case, general industry workplaces do seem to potentially be getting a little bit quieter over time. So that's general industry data, maybe not of so much interest to everyone on the call, but we also have close to 1 million MSHA measurements here, made again for compliance purposes, and now we're still looking at the average TWA, the average of all the time-weighted average measurements made by each compliance visit between 1980 and 2015. And again, we still see this declining trend in noise levels according to PEL, or permissible exposure limit measurements, and also since 2000 with the revision of the MSHA noise regulation, we've seen a bit of a downward trend in action level measurements as well. Though I think probably most of us could agree, without even any statistical analysis, the trend since 2000 has been much flatter since, for example, the trend from 1980 to 2000. So a couple things to take away here. Number one, you have this tool available. If you're interested in kind of national estimates for a particular job title in your mind, you can go to the GEM and look that up. And it's also allowing us to do this very high-level analysis that indeed does show that mines got quieter over about a 30-year period until 2000, but that trend has largely arrested. So hopefully some of the noise control and hearing protection talks that you'll hear in a bit will help you identify ways to move us forward here. So I want to spend just a few minutes talking to you about a couple of primary non-auditory health effects. So I think everyone is aware that noise leads to noise-induced hearing loss with sufficient exposure. However, many of you may not be aware that noise is also increasingly linked to cardiovascular disease, specifically to high blood pressure, to heart attacks, and to stroke. And if you think about some of the top killers of workers, and absolutely the top killers of Americans in general, it's these three health outcomes. So you might ask yourself, well, how is noise possibly causing heart disease? And so others, not myself, have created some models here to try to communicate how that might happen. So we know that noise is just a general systemic stressor. It results in a fight or flight response, an adrenal response. And we know as your system becomes stressed, you have a hormonal release that can increase your blood pressure, increase blood glucose, blood viscosity, and all of these things can subsequently lead to things like high blood pressure, stroke, ischemic heart disease. But we also know that noise has indirect pathways. So it can be not a direct disturbance in the workplace, but if your workers are also sleeping in a noisy environment or trying to communicate in a noisy environment, that can lead to effectively the same kind of stress reaction, and all of that cascade can ultimately result in cardiovascular disease. So I've taken a look at the literature and am continuing to do so in a couple of different systematic reviews, but I want to tell you that there is a pretty compelling body of literature already that suggests that your workers may be at risk of elevated or high blood pressure if they have a TWA exposure that doesn't even reach 85 dBA on a time-weighted average basis. And unfortunately, the risk for ischemic heart disease and stroke also appears to become important below our threshold at which we become concerned about noise-induced hearing loss, in other words, 85 decibels. And so I'm saying this looking at a number of different studies in the literature, and there are others, including this paper here, who have looked at individual studies. So there's 3 studies listed here, and have looked at the risk associated with each of those studies and then come up with an overall estimate of risk. And in this case, they find the overall estimate of risk to be significantly elevated. So this is one concern that we need to be aware of for miners in noise. Another risk is the risk of injury. And so this is a conceptual model that I've put together trying to link noise exposure to injury. How might that happen? Well, noise exposure can lead to hearing loss or can also cause communication difficulties. Both of those things can add to the stress that an employee has, and we have pretty good data that stress and injuries are linked. Stress can be a fatiguing element, and we know that tired and fatigued workers are at greater risk of injury. Noise exposure or hearing loss could lead directly to injury. So if a worker can't hear a warning sound and they're unable to extract from an emergency situation, maybe they get injured that way. Now, of course, all of these things are only a risk if the person is already doing a physical activity that's hazardous, but I don't have to tell you that there are plenty of those types of activities in mining. And so if we take a look at what the data have to say, we can see that there's a number of studies that actually have found that there is an increased risk of injury for workers who are in noise. But it appears to be primarily for folks that are in noise above a level which we're already concerned about hearing loss, again, at or above 85 dBA. And there's some suggestion in the literature that for noise, it might not just be the TWA, but rather some brief sort of transient high-level exposures to noise. So the graph on the lower right here is actually showing for different noise levels how much your risk of getting injured goes up. And so you can see we're looking here at different time periods. So if we're looking at the noise 5 minutes before an injury occurred, 10, 15, up to 1 hour before an injury occurred. But we see at all of these noise levels, the lines are trending upward, meaning sort of regardless of which time window we look at, the higher the noise, the more likely the worker was to report an injury or a near miss in this case. And this was work we actually did in firefighters. And the other thing I'll mention here is that it seems like if you're in noise above 85, you're already at an elevated risk of hearing loss. That hearing loss can actually put you at additional risk of having an injury. And we've seen in manufacturing workers that having a hearing loss and having tinnitus, ringing or noise in your ears, puts you at even increased risk. So mining, as we've already heard, is a workforce where there's lots of hearing loss, potentially lots of tinnitus. If you combine that with noise, these workers may be at much increased risk of injury just due to those factors. And then I want to wrap up by saying this is not a comprehensive talk by any means. There are many other health effects that have been associated with high noise. So a decrease in cognitive performance. You're not thinking as clearly when you're in high noise. There's also evidence that having a hearing loss can lead to cognitive decline, so maybe your decision-making skills are impaired, and of course those are critical in a hazardous workplace. We know that noise is associated with stress and increased absenteeism, so people taking more time off work. We absolutely know that noise is associated with reduced sleep quality, and again, fatigue and disruption of sleep are both very strong predictors of both injuries and cardiovascular disease. There's some evidence that noise can disrupt your hormones in a way that might lead to diabetes. And there's also, for minors who might be pregnant, some evidence that high noise is linked potentially with having a premature baby or a baby that has low birth weight and is at risk of other health impacts. So the take-home here, and I'll wrap up, is simply that noise-induced hearing loss in the workplace is very important. This is a debilitating and irreversible condition, but it might only represent basically the tip of the iceberg here in terms of the health impacts of noise in mines specifically. And so maybe pitching that in a more positive way, if you can introduce interventions that are going to reduce workers' noise exposures, maybe you're not just reducing the risk of hearing loss, maybe you're also preventing heart attacks and hypertension and strokes, all great things. So with that, I am out of time. I will wrap up here, and I don't know if we have a moment for questions. I'd certainly welcome them if we do, but otherwise I would encourage you to follow up with me either by phone or email, and if you're interested in any of the work we're doing, please don't hesitate to reach out, or you can take a look at our website. And so with that, I will thank you very much for your time, and if we have a moment for questions, I can do that as well. I'll defer to the moderator. Thank you.
Good afternoon. My name is Hugo Camargo, and together with my colleague, Dr. Amanda Azman, we will be talking about hearing loss prevention work conducted by NIOSH in the mining sector. Our ultimate goal is to reduce the incidence of hearing loss among the mining population. To achieve this goal, we develop noise controls for various mining equipment. We provide technical support for mining stakeholders. We provide training, we evaluate and document the effectiveness of noise controls, we facilitate their commercialization, and we also assess current practices on topics such as implementation of hearing conservation programs, and we provide recommendations. During the research process, we conduct acoustic measurements both in our laboratories and also in the field. Our laboratories include a reverberation chamber that is NABLab accredited and that we use to measure sound power as per ISO 3741 standards. We also have a HEMA anechoic chamber that we use to identify and locate dominant noise sources on a particular machine, an auditory research lab that we use for hearing protection device testing and also auditory testing. And we also have a hearing loss prevention mobile unit that we use to conduct our auditory tests in the field. Our past research projects include evaluation of electronic hearing protectors, development and implementation of engineering noise controls for continuous mining machines, roof bolters, vibrating screens, hold tracks and LHDs, air carbon arc cutting and gouging, and long wall mining systems. In the following slides, I will provide a very general overview of 3 of these projects, which involve continuous mining machines, roof bolting machines, and the most current project that involves jumbo drill machines. On the continuous miner project, the objective was to develop engineering noise controls that would reduce the noise level below 90 decibels at the operator's location. Initial noise source identification efforts use acoustic intensity mapping. This approach required hundreds of measurements to be taken on a grid around the machine, as you can see in the upper figure. And this was for every single configuration. Therefore, it was very time intensive. To expedite the process, microphone phase array technology was implemented. Using this new technology, the testing time was reduced from a few weeks to less than a day. Phase array measurements show that the dominant noise source on these machines is the conveyor chain, and more specifically, the impacts between the conveyor chain and the tail roller. Therefore, the approach that was taken to reduce this noise source was the addition of damping by coating the flight bars of the conveyor chain using a urethane layer. This slide shows a beamforming map when the microphone array was in the overhead location. From this map, we can see that the noise from the impacts between the tail roller and the conveyor flight bars at a particular frequency, which in this case was 1000 Hertz. This other slide shows the difference between the standard steel chain, which is shown in the top figure, and the urethane-coated conveyor chain that is shown in the bottom. From these figures, we can see that the noise sources at the tail roller are significantly decreased after coating the flight bars of the conveyor chain using a urethane layer. Several noise controls were developed throughout this project. These controls involve the urethane-coated chain, which provides a reduction of 7 decibels. Noise controls for the dust collection fan that were developed in collaboration with Penn State that provide a 5 decibel reduction. The urethane-coated tail roller, which provides an additional 2 decibel reduction, and also a dual sprocket chain, which provides a 3 decibel reduction. The partners that collaborated with this project include Joy Global, Howden Buffalo, Peabody, Consol Energy, the Cincinnati Mine Machinery Company, and CUE Corporation. On the roof bolting machine project, the objective was to identify, develop, and implement engineering noise controls to reduce the operator's noise exposure. To identify dominant noise sources, we conducted microphone phase array measurements in our HEMA anechoic chamber, as you can see in the top figure on the right side. The results from these measurements show that the drill steel, also known as the drilling rod, is the dominant noise source during the drilling process. What is happening in this particular case is that the vibrations generated by the interaction between the bit and the rock are being transmitted to the drill string, which is radiating most of the noise. Based on these results, the approach that we used to reduce the noise was by means of a vibration isolator and also by the implementation of an acoustic barrier. These noise controls were fine-tuned and experimentally tested to evaluate their performance. This slide shows a few acoustic maps for various proof of concept tests that we conducted during the initial stage of the project. And all these maps are for a particular frequency. In this case, it was 3,150 Hertz. As I mentioned before, one of the solutions that was developed during this project is a vibration isolator noise control. This control isolates the vibrations transmitted from the drill bit into the drill string. As shown in the figures on the right side, this device consists of an inner and an outer steel shells, which are separated by a viscoelastic material in between. The most challenging part while designing and building this noise control was to keep the internal and the external diameters the same as those in the standard drill steel. This noise control was tested in the lab and also in the field, and it showed that it could provide a reduction of 3 to 5 decibels. The other solution that was developed during this project has the form of a collapsible acoustic enclosure. The figure on the left shows this device right before drilling a hole during a lab test. The device consists of a bellows and 2 metal fittings on each end. The fittings near the drill bit have a friction mechanism that keeps the bellows up towards the roof, and that allows it to slide down as the drill still progresses into the hole. The figures on the left show this noise control in its fully extended